Hello everyone, and welcome to another video in our series of SPSS. Before we start, don't forget to subscribe to my channel for more videos on how to do statistical analysis using SPSS and Excel. In this video, I'll be showing you how to perform a one sample t-test for one mean using SPSS 29, which is similar to my other video on SPSS 26, except right now SPSS gives us the output for p-value for one tail and two tail test. So to start, we're going to open SPSS. As you can see here, so I'm performing a t-test on, let's say, age. In order to do that, we have to go to Analyze and go to Compare Means and Proportions. And of course, we're going to go to one sample t-test. So first thing I'm going to do is I'm going to add the age variable. And here we need to enter the test statistics or the test value. What's your claim? The age is at least, at most, equal, not equal, 26, 27. So whatever you have in the claim, that's your test statistics. Let's assume I'm testing that the age is at least 26 or at most 26 or equal 26. So we're going to enter the test value here, the test value, which is the one in your claim. And we're going to go to options, and this is where you have to be careful. See, SPSS doesn't ask for the level of significance. It doesn't ask for alpha. It asks for the confidence level percentage, the level of confidence. So if alpha is 5%, does that mean I have to enter 95% here? This is where you have to be careful. If your test is two tail, then yes, 5% will be divided on both tail. And remember, the confidence level is what's in the middle between the two critical value, between the two tails. So in this case, I have to enter 95% because alpha is already 5% divided on both tails. So each tail is 2.5. The middle is 95. But if alpha is one tail 5%, doesn't matter if it's left or right, one tail. So I have to assume if there is 5% on the other tail, so the confidence level in this case will be 90%. Because the middle area is 90%. Because alpha is on one tail. It's not divided on both tails. So what's left from alpha to the left is 95%, but it's not the confidence level. So this is just the thing with SPSS. If your test is one tail, is different than if your test is two tail in terms of what do I enter here as my confidence level. If your test is two tail, you take just 1 minus alpha and you enter it here. So alpha 5%, you enter 95%. Alpha 2%, you enter 98%. But if alpha is one tail, you have to take 1 minus 2 alpha and enter it here. So alpha 5%, you enter 90, not 95. If alpha is 2%, you enter 96, not 98. Okay, so just be careful with this. Other than that, that's all what we need. When we click OK, SPSS will give me the test statistics, the mean, standard deviation, etc., and the result that I'm looking for. Keep in mind, this is the test value. This is the t value, 1.490 degree of freedom. And this is the difference between SPSS after 27 and before. Before it used to give me only the two-sided p-value. Now it gives me the one-sided p-value and the two-sided p-value. So one tail p-value, two tail p-value. Keep in mind that the two tail is twice the one tail. So if you take 0.74 multiplied by 2, you get the 0.148. And you can see here the confidence interval is for 95%. If I change it to 90 because it's one tail, you will get different confidence interval. Okay, so I will repeat the steps. All you have to do is go to Analyze, compare means and proportions, one sample t-test, add your variable, put the test value, make sure you put the right confidence level, and this time I'm going to put 90%. Let's assume it's one tail. If it's two tail, as I said, 1 minus alpha, one tail, 1 minus 2 alpha. And you will see that you will get the same output. The p-value does not change. It's still the same p-value. The difference will be the confidence level between 95 and 90%. So in fact, what you enter as the confidence level doesn't affect the p-value or the t-test, but it affects the confidence interval. Thank you for watching, and don't forget to subscribe for more videos.